Now, instead of talking about slope, we're going to talk about another part of a linear graph, the x and y intercepts. X-intercepts mean where your graph crosses the x-axis, the horizontal axis. Y-intercepts mean where it crosses the y-axis, which is the vertical axis. And I'm going to give you some things to remember for how to look for x and y intercepts in each different representation. So you should have some blank space off to the left of this graph, and that's where you're going to write this. So when we're looking at a graph, you're going to look, use your eyes, and you're going to look for where it crosses, it being the line. Look for where it crosses. So we're going to find our x-intercept and y-intercept. So my x-intercept of this graph is where it crosses the x-axis, which is right there, which is at 2, 0. X-intercepts and y-intercepts need to be written like points. Your y-intercept is where it crosses the y-axis, which is at 0, -3. It's not the same thing as slope, so you don't want to do rise over run before talking about intercepts. So I want you to pause the video and try the next 3 graphs identifying the x and y intercepts and press play when you're ready to go on. So x-intercepts, once again, are where it crosses the x-axis. So it crosses the x-axis in the first graph at -6, 0. I'm going to go horizontally. The next one hits the x-axis at the point 5, 0. And the last one hits the x-axis at the point 4, 0. Y-intercept is the same idea, but it's where it crosses the y-axis. So the first graph crosses the y-axis at the point 0, -4. The next one crosses at the point 0, -6. And the last one crosses, sorry for that beautiful line, at 0, 2. So when we want x and y intercepts from graphs, you're seeing where does it cross the x, where does it cross the y. When we want to do it from tables, we're going to look again, and what we're looking at is look for 0. If you look back at the graphs we did, notice how each of my points has 0 in it. So an x-intercept happens when y is 0, and a y-intercept happens when x is 0. So one thing you can do to go ahead and help you is to fill in that part of your point. So an x-intercept means that your y value is 0, and a y-intercept means your x value is 0, and now I look in the table for the things that match. So I find a 0 in these 2 places. What is the first point? -4, 0 for my y, my x-intercept. And then the 0, 6 is my y-intercept. If you don't remember, what you can do is just imagine graphing these points. So if I imagine graphing the point -4, 0, that would be left 4 and up 0. So that's on my x-axis. So I know that this needs to be my x-intercept, leaving the other point with the 0 to be my y-intercept. Once again, press pause and try the next 3 tables on your own. First, I'm going to find all of the zeros in all my tables. Obviously, it gets more complicated if I can't see where these zeros are in the tables, but for this section, we're going to focus on when it is in my table. So all of my points have a 0. I've circled 2 points in each of these, so I'm covering my x-intercept and my y-intercept in each of them. I just have to decide which is which. So the point 0, -6 is going to be on the y-axis, so that's my y-intercept. You can also do what I did in the first example where I said an x-intercept means that your y value is 0, and then match that up with the correct point from your table, which would be 2, 0. So let's try it using that method. An x-intercept means that y is 0, a y-intercept means that x is 0. So matching with the points I circled, that gives me 3, 0 for my x-intercept and 0, -3 for my y-intercept. X-intercept means y is 0, y-intercept means that x is 0. And matching up with my table, I have -4, 0, and 0, 10. Notice I didn't do, so don't write this down, I didn't do any of my arrow stuff like I have to do with slope, because slope is change in y over change in x. It's a ratio or a fraction. Intercepts are points, so we don't need any of the arrow stuff if I'm doing x and y intercepts. The last way that we need to be able to find x and y intercept are from equations. So the first two things we looked where it crossed the x-axis, we looked for 0. Now for equations, we're going to plug in 0. So what I do is I split up my workspace into two distinct sections. And at the top I write my x-intercept means that y is 0, and a y-intercept means that x equals 0. And now I take my equation, 4x minus 2y equals 12, and I'm going to, if I'm finding an x-intercept, substitute in 0 where I see a y. So everything else in the equation stays the same. 4x minus 2 times 0 equals 12. Well, when we're doing 0, 0 is a special number. What happens when I multiply something by 0? Well, that really just goes away, right? Because -2 times 0 is 0. And now how do I get x by itself? You're going to divide by 4 on both sides. So x equals 12 divided by 4 is 3. So my x-intercept would be the point 3, and my y value is going to be 0, because an x-intercept means y equals 0. And now I repeat the same process for my y-intercepts, but this time I'm going to substitute the 0 in for your x term. And what you want to be careful when we have this and we have subtraction is that we don't, whoops, that's not equal to 0. Sorry, equals 12. Is that we do not lose that negative. So we just said when I multiply by 0, 4 times 0 is going to give me 0. But what I'm saying is don't lose this guy right there. Okay, and now how do we solve for y? We divide by -2 on both sides, and I get y equals -6. So my point is going to be 0, -6. The next equation looks a little bit different, but we're going to do the same process. So split up your workspace into two places. X-intercept means that y is 0, and y-intercept means that x is 0. So when I substitute in 0 for y, I get that 0 equals 6x minus 12. And now it's a two-step equation. We're going to add 12. So 12 equals 6x. And divide by 6. So x equals 2. But an x-intercept is a point, so it's the point x value of 2, y value of 0. Same idea for the next part. Y equals 6x minus 12. And then we're going to substitute in 0 for x. So 6 times 0 is 0, and 0 minus 12 is negative 12. So the point 0, negative 12. So what were our three different things for x and y intercepts? We look to see where it crosses the graph, we look for 0 if it's in a table, and we substitute or plug in 0 if it's an equation. Don't forget to turn it into Google Classroom.